Go. Oh, hi everyone. So it looks like we already had people waiting in the room for us. You can see all the participants going up nice and quick there, which is ideal. Hope you're all enjoying the lovely weather that we've got going on today. Seems to be that looks like our British summer is over. We were actually getting our cars cleaned as the bad weather hit, unfortunately. But never mind, it was nice while it lasted. Pretty sure, I know I've pretty much spoke to a lot of you on LinkedIn or over email and things like that. For anyone who doesn't know, this is my colleague Ellie. So Ellie's part of our marketing team as well here at Ronald James. I'll just give it one more minute to see any last minute people tuning in. But looks like we've got quite a few people already joined us. Definitely. It's great to see everybody tuning in. I mean, it's up to you, Phil. Are you ready to I know you've got like a bit of an introduction to sort of kick us off with.
Yeah, we can get started whenever you're ready.
I'll just let you. I'll let you take it away.
Cool. Let me share my screen. Cool. So one thing I will say at the start. So we'll make time for questions at the end, but if questions do pop up during, I probably won't see them. So I'll have a look at the end and see if there's any questions and things like that. But yeah, so this is a session on TypeScript, which I'm sure you know because you all signed up for it. And it's looking at some of the advanced types to understand the fundamentals. So let me just do a brief intro of myself. So I'm Phil Johnson. I'm an engineering manager and currently work at a company called Mkodo. Got 20 years experience in software development, and a lot of my career has been there's been a focus on agile and XP practices, clean code and architecture, solid design principles, and software craftsmanship. At Mkodo, and I'll be quite quick with this because I know you all want to move on to the TypeScript, but we do have a couple of open positions at the minute. So we do mobile and web apps in the online gaming sector. We've got a few open roles at the minute, which Ronald James, who hosts this meetup, are helping us recruit for. So we've got iOS, so mid and senior level iOS developers, which is Swift at Mkodo. Android, which is Kotlin, and again mid and senior Android developers. React, which is Redux, Next.js, and TypeScript. So anyone who's along here tonight might be interested in those roles, and we're also recruiting for QA engineers as well. So if anybody is interested in those, if you want to reach out to Lucy, who was you heard at the start there, Lucy Kay or Daniel Blackwell as well from Ronald James, you'll be able to find them on LinkedIn, or I'm sure Lucy will be able to help you out if you ping the DevHub North LinkedIn page. I will hang around at the end as well after we finish the session and done any questions or discussions about TypeScript. I'll hang around, and if anyone wants to hear more about Mkodo and the roles we've got open and our ways of working and things like that, I can hang back and go into things then. But for now, let's get into TypeScript. So some of the things we'll be talking about tonight is, I'm guessing there's people of varying levels on the call. So I figured I'd start just very briefly with what is TypeScript and why do we use it? And then I'll start going into enums. So enums in TypeScript can be useful, but they can be a little bit problematic. So we'll have a look at enums, and that helps us as well start to understand some of the basics of TypeScript, how TypeScript works and what it does. From enums, we'll move on to a couple of, it feels like more advanced types. So union types and intersect types. So I do a lot of recruiting in my current role and some of my previous roles. And one of the things that kind of spurred me on to do a session on union and intersect types is when it comes to interview questions about React, it seems to be a couple of types that aren't very well known about. It doesn't feel like very many people have had much exposure to them. And I found when I was learning about TypeScript, looking into these two types, or union types and intersect types, really helped me think about and understand some of the basics of TypeScript and how TypeScript works. So along the way, we'll kind of look at type literals, type narrowing and widening, type level and value level code, type guards, and static type checking as well, which is something that I thought I knew about from my time in C# and .NET, which is my background, but I was quite surprised with how TypeScript actually does its type checking. So you're probably pleased to hear that that is it for slides for the night. So I've been praying to the demo gods that everything will run for me, but the rest of the session will be in Visual Studio Code. So I'm currently running Visual Studio Code, got a React plugin installed, and all I have open currently here is, actually, let me just move my bar for Slack, to Zoom along so that I can change files. But all I've got here in preparation is a JavaScript file. So I just created a devhubnorth.js file, and it's got a simple function, and it's called log color. So my kind of my conceptually here, I'm thinking color is going to be passed in as a string in JavaScript. We can't control it any more than that, because we can't say what type we actually expect. And I've got a line here that is going to call that function, and all the function's going to do is log out whatever we pass in, and it's going to log out the length of the string that's passed in. So what we'll do is, all I've got here to just to go into the solution to start with. So all I've done in preparation is, for anybody who doesn't know much about JavaScript, I guess, or hasn't run it like this, so you need a JavaScript engine to run JavaScript. Normally that's in a browser if it's a website, but running a script like this, you can run it in Node. So we're using Node.js here. One of the things that you get with Node is NPM, which is a package manager. And that's where these package files come in. So I'll go into the package file shortly when we start talking a little bit more about TypeScript. But in terms of JavaScript, I just have this one file, and we can run it now by just going to, let's see, if we go to Node, which will run the executable for Node, and we're going to run this script, which is devhubnorth.js. And what it'll print out is it'll print out the color red that we've passed in, and it'll print out the length, which is 3. We can change that to other colors. So we can change that to blue, and we can run that, and it'll print out blue and 4. And we can change it to other things as well. So the function's obviously saying it's expecting a color, but we could change it to tomato, and that will run, and it won't complain. So one of the big problems, as well as just being able to pass anything in, is if we log out. So let's try passing in null. And in reality, in a bigger JavaScript kind of file or system, you might get nulls passed in that are coming from data where there's been no data or something like that. But let's just try passing null straight in there and see what happens. So we get an error, and it's saying that we can't read the property of length on null. And this is where TypeScript comes in. So TypeScript enables us to limit what this thing is that is about to be passed in. So how do we start doing that, I guess, is the question. So first thing that we can do is with Node Package Manager, we can install TypeScript. You can install it globally, but for this demo, I've installed it as a dev dependency. The reason why I've installed it as a dev dependency is because you never really run a TypeScript file. So with TypeScript, there's a compiler called it's the TSC executable, which is the TypeScript compiler. You run that as part, it's introducing a build process. So what we had previously running just the JavaScript file is, you would call that kind of the run process, I guess. When we introduce TypeScript, we introduce a build process. And actually what we get out of that build process is JavaScript. So we're only ever running JavaScript, although we type our code in TypeScript. So let me just rename this file to be devhubnorth.ts, which is the TypeScript extension. And straight away, you'll see I'm going to get some, I'm going to get a squiggly line underneath color because it's saying that color implicitly has an any type. So what does that mean? So if we have a look, when we install TypeScript with Node Package Manager, it installs TypeScript in the Node modules folder, and it creates this tsconfig.json, which is the TypeScript config. And this is where you just define kind of what you want TypeScript to check for. I think I've got the default here. Maybe I've changed the version of ECMAScript that it's gonna transpile to, which we'll talk about shortly. But if we have a look down, it tells you a lot of the things are commented out, so it's quite clear what you can set in your TypeScript config. But if we look down here, we've got strict option is set to true. And this is set by default, and it is one of the most powerful kind of options in the TypeScript file. But you can see here, no implicit any is set to true. Now, what we can do to fix this is we can explicitly say that this is any. And what we've done here is we've introduced TypeScript. So the JavaScript, which we hadn't changed, is called value level code. Type level code is TypeScript. And in this file so far, that's literally the thing that I've highlighted there, which is the colon and any, is the only it's the only type level code that we have in the file. Now TypeScript isn't complaining about anything now, so what we can do is we can compile the file. So let's do the build step that we have now. So we'll do npx, which will take us into the Node modules folder, and we'll do tsc, which is TypeScript compile, and let's do devhubnorth.ts, and that should compile it. And what we'll see now is we have a JavaScript file now, as well as a TypeScript file. So if we go into the JavaScript file, you'll see the only difference is, apart from stripping out some white space, the only difference is it doesn't have the type level code in. So TypeScript has kind of three main kind of steps, if you like, to that build process when you run TSC and pass some TypeScript into it. It does type checking. So it'll check that the type that we're saying we're passing in is the type it expects. It strips out the type level code, and it transpiles to the version of ECMAScript that you want to output. The reason why you would normally output to an older version of ECMAScript, if we have a look in the tsconfig file, is it means you can write your TypeScript code and your JavaScript parts of that as the modern version of ECMAScript, but it'll output JavaScript that can be understood by older browsers and things like that. So it means that when the browsers catch up, you don't need to change the code that you're typing because it's in the modern version. You just change the version of the code that's going to be output that'll be run. So that's a JavaScript file that's being created. If we run that, it should. Let me see. Did I save that? So it's getting null, but that is, so we're still getting a null error, but that's because we're allowing any to go in the TypeScript, so it's compiling fine. So it's letting the null go in. So what we can do is we could say that's string, and straight away it tells me that I now can't pass null in. So that limits it to string, but we still have the problem that we're passing in tomato and we're expecting a color. So the easiest way to sort of get around that, I guess, is to introduce an enum. So let us just introduce an enum, and we'll call it color enum, and just get rid of these for now. So by default, an enum will have an integer index. So let me save that, and now we can say this is of type color enum, and straight away I can't call length on it, which I wouldn't expect because I'm passing in an enum, and it doesn't like tomato. So if I take tomato out, and I can now say, give me something that's of my color Enum, and I get nice IntelliSense. So it's telling me exactly what I can pass into this function. So I'll say pink, and that's brilliant. So there's no squiggly lines now. So let me save that, and let me compile it. And it's compiling nicely. Let's have a little look at the compiled file. So you can see here that it's created this function which kind of has some arrays inside of it, and you can see it's created an integer-based index for the arrays. Now what this means is, so let me run that. Now, what it means is, so when I say log color enum.pink, it's going to log 2 because it's going to get the index, the integer index from this array when it passes in color enum.pink. And this is one of the problems with enums in TypeScript, because that's great. It limited me to only be able to select the 3 things from my color enum. But one of the problems with this is all the TypeScript is really checking when you have an integer-based index enum is that you're passing in an integer, not the enum. So what I can do is I could pass in 2, in which case it would give me exactly the same output when I run it. But what I can do as well is, so it's not checking that it's within the range of the enum integer index. So I can pass in 42 to that, and that's not going to complain about anything. It's going to compile fine and it'll run fine, but I don't have a color that matches 42. So that's a problem in itself. Now, what you can do is you can change this to be a string-based index. So let's change that to be red, and this to be, change that to be orange, and this to be pink. We've now got a string-based index enum, which isn't too easy to say. And what happens now is we get a red squiggly line with 42. So it's not going to let us pass 42 in. It's not going to let us pass any kind of just any string in. So what it'll do now is it will limit us to the enums the enum values that we've got. So we can do red, and what we get now is if we compile that and run it, and it looks nicer. It says red. So straight off the bat, I think if I was using enums in TypeScript, I would suggest using string-based index enums like we've got here. But one of the problems, one of the good things with TypeScript, I guess, is you can do something called declaration merging. So I don't think there's much that you can do declaration merging with, but enums is one of those things. So what you can do is, if you're following the solid principles and you've got a file that you may not be able to update, it's got an enum in, you might not want to update it, but it might be an enum that's declared in a third-party thing that you want to add some values to. So you can modify, you can extend it without updating it by just declaring something with the same enum name. And you can see it's telling me that I've got a duplicate declaration. So let's change that to blue, and let's change that to blue, and let's compile that. And what we have now is, so we can pass in red and we can pass in blue. And you can see here, although it's declared in 2 places, it just gives us a nice IntelliSense with all of the things. So that's brilliant. So I can say, give me blue, and if I log that out, it's going to say blue, which is brilliant. But one of the problems with declaration merging is, especially when it's in different files and things like that, you can imagine it's quite easy to copy and paste and actually just leave a value in. You know, you change this this first value to blue, and then you get a Slack message from your boss, you kind of get distracted, you end up on a Zoom call, and you come back and you've forgotten to change the value back. Now, it did warn us with the value itself when that was duplicated, but it doesn't warn us when the index is duplicated. So it's very easy to start introducing copy and paste errors with declaration merging like this. So you can see there, I'm passing in the color enum.blue, but it's printing out red because it's printing out the index, the string index of that thing. So enums can be quite problematic. So I guess what's the way that I would use rather than enums for something like this? So this is where we start looking at union types. So what we get in, I guess one thing to show first of all, so a literal type in TypeScript is something that's a literal kind of value. In TypeScript, literally everything is a type. So an enum is a type is a type, a function signature is a type, a function itself is a type, and you have something called literal types. So let's have a little look. If we do, so if we do const, let's just do test equals, let's see, equals, let's just do red. So this is, this is a constant. If we hover over test, TypeScript is implying that it's red, and this is called type narrowing in TypeScript. If we change this to be a let, where it's a variable value, TypeScript will then imply that it's a string, and that's called type widening. So TypeScript will narrow something implicitly to be the type, the narrowest type that it can be. So we can change test here to be blue, because test is a string. If we were to explicitly say that this is a literal type or a type literal, and we were to say that that's red, we can no longer change it to blue because blue is not assignable to the type red. So that's type narrowing and widening. And we'll look at that in a little bit more detail shortly, but it also shows kind of type literals. So what we can do is we can declare a type, which is a union type. And we can say it's, so union type basically is, you're saying it's anything within this range that you separate with the kind of pipe symbol or the or symbol. So you're saying that this, if we're expecting a type of color union, we want something to be either the string red or the string yellow or the string pink. So if I was to change this to accept color union instead of color enum, we still get IntelliSense, but it will literally just allow these three strings. And this is, I think, is a really good use for union types in TypeScript. It is very much, you know, there are problems with enums, as we saw above, and I think this really gets around those problems. So personally, if I'm writing TypeScript, I always choose a union type of type literals over an enum, because I find it gets around some of the problems with enums that we saw. And you still can actually, so you can extend something like this in the same way that we did with declaration merging. We can create a new union type where the type is a union of either our existing type or the additional types that we want to add to it. And now when we go to log color, we should see, if I take out the things that are in there, it needs to be extended color union there. So now when I get the IntelliSense again, and it gives me the values of both of the declarations, I guess, of the type, the one that I'm extending, gives me the values that I've added to it, and the type that I've extended. So yeah, I find unions of type literals are very versatile. They're easy to extend and get around the problems with enums. And that brings us nicely into union types themselves. So what demo about type checking would be complete without bringing a duck into it? So the old kind of duck typing kind of example, I guess, here. So what defines a duck? And this in TypeScript, I would call this a simple shape. So we're declaring a type. It's got some simple string members on that have kind of explicit names. So we're saying that a duck, if it walks like a duck and talks like a duck and swims like a duck, essentially it is a duck. So let's have a little look at declaring an instance of a duck. So we've got a duck here, and it can walk, it can talk, it can swim. If I take swim off, it will tell me that this isn't a duck because it's missing swim. So again, this is the power of TypeScript. It kind of really checks that we're passing things into functions that we expect, but it also checks that if we say something is a type, that it is actually that type. So we've got a type now, which is, well, we've got an instance of a type. We've got a type of duck, and we've got an instance of that type, which is a mallard. And it walks with a waddle, it talks with a quack, and it swims with a paddle. So if we bring something in now where we're logging that out. So you can see here we're logging out duck. We're saying that we expect duck to be of type duck, which is this type that we've declared above, and it's gonna print out basically how the duck walks, how the duck talks, and how the duck swims. So let's try logging out our mallard instance, or our mallard, which is an instance of a duck. And you can see straight away it's letting it in because it is a duck. So let's compile that. And let's run it. So we've run it there, and you can see it's logging out the duck, it's waddling, it's quacking, and it's paddling. So let's have a little look at the JavaScript that's got created there. And you can see here in the JavaScript that's got created, there is no concept of a duck type. There's the instance there's the instance mallard that we created. It's taken out the fact that we've said that, so it's taken out the type level code in that section, which is where it says that a mallard needs to be a duck. The JavaScript doesn't care about whether this is a duck or not at this point. So it logs out the duck, and it's calling that. It's probably worth saying as well, we can actually change the JavaScript that gets output, and we can say, all right, log duck, and I'll pass in null to that. And that will save, and it'll run. It won't run fine because it'll get an error. And this is the value of TypeScript. You do all your code in the TypeScript file, and it would tell us straight away if we start doing things that that are going to cause us problems and errors in the JavaScript. So we've got a duck there, and it's great. It's telling us that it's a duck, and it's checking that it's a duck. So let's try creating a different type of a different animal type now. So create a type called ape, and an ape is similar to a duck. There's some similarities. An ape can walk, it can talk, but it can swing. So an ape can't swim, but it can swing. Now, if we create an instance of an ape, and I'll just call this instance ape with a lowercase a. So an ape can walk on all fours. It talks gibberish. So I had to Google this when I was coming up with this demo, because I didn't know what an ape spoke or talked, and yeah, apparently it's gibberish, which is a word that I've used throughout my life, and never realised that it was the official kind of language of an ape. And an ape can swing through the trees. So what we can't do now, so remember our log duck function is expecting a duck. So what TypeScript shouldn't let us do is it shouldn't let us pass in an instance of an ape into that log duck function, which it doesn't. So that's brilliant. That's exactly what I would expect from type checking. You know, it's saying we're expecting a duck. This is an ape that you're trying to pass in. So if I hover over that, it tells me that. It's not just the IntelliSense either that happens with. So when I do the build kind of step, when I call the TypeScript compile, it will tell me exactly the same thing it's telling me when I hover over it. It's saying this is an ape and it doesn't swim. Now, this is interesting. So it's not telling me that it's not a duck here. What it's telling me is that it's an ape and an ape doesn't swim. And this is where the type checking in TypeScript becomes very different to what I'm used to. So it turns out I'm used to, like I said at the start, I'm used to C# and .NET, and I'm used to static type checking. But it turns out there's two different types of static type checking. There's nominal type checking, and there is structural type checking. Now, C# and .NET is nominal type checking, which means it goes by the name. So it looks at the name of the type or the name of the interface and checks that the name of whatever you're passing in is of that type or implements that explicit interface. TypeScript's different, and this was a learning experience for me. So TypeScript does structural type checking. So it's not actually checking that we are passing in an instance of a duck when we say that it's a duck that we expect. What it does is it checks the structure of the thing that you're passing in, and it will it'll let it in if it matches the same structure. So an ape was similar to a duck. They can both walk and talk, but an ape can't swim. But if I make swim optional on duck, you can see here there's it's still letting me call duck.swim on this function, and still logging that out to the console. But down here, it's now letting me pass in an ape to our logduck method. And an ape is of type ape, but our logduck function is expecting something of type duck. So again, that was really new to me, the whole kind of structural type checking rather than nominal type checking. And I think when we get further into union and intersect types, understanding that kind of structural type checking can really help. So we've got an ape here that's been logged out. But what's going to happen, because we're going to come in here, we're going to pass an ape in. It's not a duck that's coming in, it's an ape, albeit an ape in duck fancy dress. It's going to say it's logging out a duck. It's going to walk like a duck, talk like a duck, and an ape can't swim, but swim is optional now on duck, but it's going to try to call it. It's worth kind of mentioning here as well that when we hover over duck, our parameter our variable there, it does tell us that it is of type duck. So what I can do now is, let me save this, and it should compile nicely, which it does. And let me see. So let's try running that. And you can see here, when the ape goes into that logduck method, it's getting undefined. So this is the very thing that TypeScript is there to help us avoid, the kind of the null and undefined errors in JavaScript. But we can fall into this trap if we don't understand the nuances of structural type checking and what can and can't be passed in, and optional parameters, optional members on types. So we're passing in an ape there to that logduck. What we can do now, just to go back to union types. So what we can do now is we can create an animal type, and we can say that it's within this range of types. So if we declare something that expects an animal, we're saying that it could be a duck or it could be an ape. We don't care which. Now, if we do that and we log it out, what we can't do now is, and you can see here when we hover over animal all the way down, it's telling us implicitly that, well, it's telling us explicitly because we're explicitly saying that it is of animal type. It tells us that animal is of animal type. Now, what we can't do if we say that it's a duck or an ape is we can't call, we can't log out the swim, because an ape doesn't have swim. So let us just see what happens when we try that. Animal.swim. It's going to tell me with a red squiggly line that it really doesn't like that. So property swim doesn't exist on type animal, and it tells me explicitly there property swim does not exist on type ape. So that's why. So even though swim is optional on duck, if you have a union type and something has an optional parameter, you can't call that in something that expects that union type. So how do we get around that? So what we can do is we can bring something in called a guard type. So what I'm about to kind of show is something that'll get you stricken off Barbara Liskopf's Christmas card list, because it's definitely a code smell, I think, for the substitution principle. Because what we're saying here is we're expecting an animal, but we can't treat all animals the same inside of the method. But what we can do is we can bring in a function that is basically going to return whether something is of a certain type or not. And what we're going to say is we're going to accept the union type as the parameter to this type guard, but we're going to return if the value is a duck. And we can define in here however we want to do that. It seems obvious for this small example that why don't we just check to see if it has a property of swim. So what we can do now is we can call our type guard before that swim, called a swim. Straight away you can see the red squiggly line vanishes. Which is brilliant. So now, like I say, Barbara wouldn't like this because it definitely doesn't fit in with her substitution principle. But we are checking if an animal is a duck before we do things on it that we would expect from a duck. And one of the kind of key things here as well to look at, so all the way down here, when we hover over animal, it's telling us that it's an animal type. But when we get into the scope of the type guard, you can see here animal changes to be of type duck. So that again is type narrowing in TypeScript. It'll narrow the type to be whatever type you need at that point inside of that scope. And if we did something else further on that and hover over animal, you can see animal then is widened again to be of animal type once it's outside the scope of the type guard. Cool, so that's type guards and union types. And I guess probably I see it as a slightly more complex type. Actually, before we move on to union types, let's just see if we can. So we're passing in, let's try passing some things into here. So we can create a, let's see, we can log our duck just to show that we can log our duck and we can log our ape. And let's see, so let's run that and see what we get. So we can run it. So here you can see it's logging the animal, it's logging out the things for the duck. So a duck can waddle, it can quack, and it can paddle. And when it gets to the ape, though, we don't get the undefined anymore because we've got the type guard on. It's not going into this this scope of the type guard. So we no longer get the undefined. So that's quite good and quite a powerful way to use union types where you have optional parameters. Moving on to intersect types. So where with the union type, we use the pipe and we declare a range of things that it could be one or the other. What we say with an intersect type is it needs to be all of the things that are within the range of the intersect type. So if we declare a type called superanimal, which is an intersect type, and it is a duck and an ape, things start to get quite interesting, should I say. So let's log out a superanimal. So we're going to log out our intersect type. We're going to say animal is a superanimal in this function. And you can see here we can call everything that's on duck and ape, because any type that we pass in here is expected to be both a duck and an ape. And if we had any other things on the end here, so we could keep going and we could, keep going. We could say it's a duck or an ape, or we could say, actually we don't have our color enum still, do we? But we could say it's a duck or an ape, or it's and it's red, which wouldn't make sense, but you'd probably have a number of other animals. But you can literally just keep going with ands, and similarly with union types, you can keep going with the ors. So if we've got this function here and it's going to log out a superanimal, so let's have a look. First of all, can we log out an ape here? And the answer to that question is we can. So it's not giving us any squiggly lines for an ape. And if we compile that and run it, you can see here, so it's logging the superanimal intersect type, and it's literally just going down all of the animal things there and logging them all out. And we're back in the realm of undefined. So we get undefined there, but the reason we can pass ape into this as a superanimal is because an ape structurally is both a duck and an ape, which we saw earlier. You could pass ape into a function that just accepts duck, because swim is optional on duck. Walk and talk are the only things that are mandatory, and walk and talk are mandatory on ape as well. So structurally, an ape matches an ape, it matches a duck, and because of that, where we have an intersect of a duck and an ape structurally matches that as well. If we try the same thing with an instance of our duck though, so let's try logging out our superanimal, and we have a mallard. So it won't let us do that. And the reason is a duck is structurally the same as a duck, but it's not structurally the same as an ape, because it doesn't have the swing member on. And it'll tell us that, right? If we hover over it, it'll tell us that it's not assignable to parameter of type superanimal, because property swing is missing from type duck, but required in type ape. So that's quite interesting. And you can see up above though, for a union type, we can pass in an instance of a duck to a function that's expecting a union of type duck and ape, because a duck is one of those things in the range, but it's not all of the things in the range of the intersect type. What we can do as well is, so we can create an instance of something that's of the intersect type. So we can create a superanimal that is of type superanimal, and this is like a robo animal type of thing. It walks on all fours, it talks gibberish, it swings through the trees and it swims with the butterfly stroke. And we can log that super animal out. And you can see there's no squiggly lines there. So let's try compiling that and let's try running it. You can see there we're logging out the super animal intersect type, and it is logging out everything there. There's the 8.1 above where it's undefined for the optional swim parameter. So if we have a look at the let's see, why is the JavaScript not update? It's because I edited it previously. So let's not save that and let's reopen it. So this is the JavaScript that we're getting output now. And again, you know, there's none of the code that we've got in here about saying what an intersect type is. So that code is just up above the log super animal, but that's type level code. So up above log super animal, we don't have anything to do with kind of that definition of that type. And this is the thing, right, with the JavaScript. It still codes, the JavaScript file is something that you can edit and save, and you know, you'll still hit your problems. But what you kind of do with TypeScript, for anybody who is new and is sort of looking to where to get started with TypeScript, any code that you've got that's JavaScript code, you can literally introduce TypeScript as an npm package to that project. You can rename those JavaScript files as TypeScript. You might have to put some any explicit things on some things that you're going to have to put types on. It'll tell you where you need to put types on for the TypeScript, but you can put any on for anything that you're unsure of, and you just want to get TypeScript introduced so that you can start getting the value of writing new code in TypeScript. You can get rid of your any sort of types over time. But the idea is that you change your JavaScript files to TypeScript files. As part of your build process, you output JavaScript from the TypeScript files. And if you output JavaScript to the same location with the same name as your existing JavaScript files, then running your app will be exactly the same, but you've got the benefit of using TypeScript and you'll have type checking in. But I think one of the things for me that's really interesting with that whole process as well is, before I sort of started learning TypeScript to me felt like a new language. It felt like it was going to be a different language. And the reality is, if you know JavaScript, you already know all of the value level code that you're going to have in your TypeScript files. The only part of the TypeScript files that you need to learn is the type level code. And that's why I think it's quite important to conceptually kind of distinguish when you're writing TypeScript between what is type level code and what is value level code, because ultimately value level code is the JavaScript code that you already know and love, and the TypeScript code, type level code, is the TypeScript extension, if you like, that you're adding to the existing JavaScript. And that was everything that I was going to go into for today. So just to kind of recap, I guess, enums can be problematic. I would avoid integer-based enums, integer index-based enums, because you can pass in any integer to those, and even TypeScript won't catch problems there. String index-based enums are better, but you can still, and I think cleaner in the sense of you can understand it more if you're logging out to a file, or if you're looking at the value of that enum somewhere. It's a little bit cleaner, I think, to use string-based index enums. But you're still kind of hitting the problems with declaration merging. So to avoid that, to avoid those problems, I would use unions of union types, where the range is a literal. It's a range of type literals, and the values of those type literals are the things that you want. You can still extend that by declaring another union type where one of the things in that range is the existing union type that you're extending, and you can add your additional type literal values into that range. If you're using union types with types themselves, then remember type guards. So anything that is specific to one of the types in the range, or not all of the types in the range, then you can use type guards, but I would avoid it. And the reason for that is, like I say, for Liskov substitution principle, you're going to end up with a lot of type guards scattered around your code. And every time you change something, or when you change something to do with that particular type, that's part of the range of the union type, then you're going to have to go around and find out everywhere you're using that type guard and see if it needs changing in there. So like with any good kind of encapsulation and abstraction, anything that basically, like if you're having to use a type guard, then it's probably something you should look to encapsulate inside of one of your types. And intersect types are a little more complex. Intersect types are where something is, it has to be everything within the range at the same time. And yeah, structural type checking again is something that if you're not aware of structural type checking, I would have a look into it, because it kind of caught me out a little bit and made me think a lot about what I was doing when I realized that actually it's not checking that it is of a certain type that's being passed in, it's checking that it's structurally the same as the type, and letting it in if it is structurally the same but not the same type. And that was everything that I was gonna cover tonight. So let's have a little look at some of the questions. So I'm using VS Code. I think I have let's see, do I have any extensions? I've got a React extension. It may well be vanilla, to be honest, that checking. Might be getting some TypeScript type checking from other things, but yeah, I think it might be vanilla VS Code that I'm using there. But it is nice. The VS Code's great for it's free, and it does give you a lot of IntelliSense there, and you can see using the terminal there, it can compile everything. The reality is as well, in your so you'd probably create a shortcut in your package JSON. You can create a script which will build your TypeScript, so run the TSC command, and then you can run, you could run do the run command as part of a script here. So you can do a script shortcut that would mean you're doing one thing. I just wanted to explicitly show those different steps. Can you merge int and string in declaration merge? No, you can't, because you could. You could do a union type of let's say of int and string. So what you could do, let me just move that out of the way a little bit so I can copy the union type. So what we could do is you could say that animal, actually let me delete that because I have the declaration further down that I can just update. So yeah, what you could do is, as a union type, you could say that it is a duck or an ape or a string or an int. Is it int? Let me see, or it would be number, wouldn't it? I think. So let's go number. So you could say it's a string or a number, and your union type could just be that. So yeah, you could have a function that says, is it a string or a number? And then you could have a function that takes in a string or a number. What you'd probably find if you have something like that is you're probably going to need to be checking the type and seeing what it is before you do something with it. So it's probably best avoided. But again, you might want to do that. Can you merge int? Sorry, that's the one we've just answered. Any reason to use class-based constructs over the type construct available in TS? Honest answer to that is I don't know of any, but other people on the call might be able to spring up in the chat and say some. But yeah, I think it's one of these things. Like I say, in TypeScript, there's so many different ways to declare things. I think there's probably people probably declare get habits over time as to the way that they do things. For the purpose of this demo, I've used type because it's quite simple and easy to say that something is of a type. But yeah, there might be reasons to use one over the other, but I wouldn't know off the top of my head. Another person, I don't think advising technical debt to new TS devs is the most courteous thing to do here by recommending they just use any and fix it later. So yeah, it's a very valid point, and any is something that's very much best avoided. In terms of kind of introducing TypeScript, it can be a halfway house to start using it. But I would definitely advise kind of if you don't have time to actually define all of the types, because you might have hundreds of files of JavaScript that are fairly big. It is a way of getting there. What you can do as well, so something that's a little bit better than any, but again, it's more work. What you can do is you can use unknown. So I mean, what we could do just to show kind of things here is, so if we said duck was any, then it would let anything in here. And it would call walk on it, it would call talk, and a lot of these, lots of things would get would experience problems. But what you can do as well, so instead of any, what you can say is it's unknown. Now, unknown is kind of, it's a little bit like any, but it will prompt you to deal with the things that you have to deal with. If it was an explicit type. So again, we're starting to bring type guards into it. So let's see if we can fix this by saying if type is duck, and it's not going to like it because it is an animal that it's expecting. So let me copy that, and let's say let's declare another type guard is really type duck, and let's say it's a let's say value is unknown, and it's not liking it because it's part of property. But yeah, you can see, so this is why kind of any feels like a reasonable sort of way to get going with your thing, because you're going to have to, before you can actually call things, if you're using unknown, you have to start doing guards and things like that, and it becomes problematic, and you might as well kind of fix the thing rather than just saying unknown. It is a very valid point though about any is very much best avoided, and that's why by default TypeScript makes you explicitly say things rather than saying that it's rather than TypeScript implying that it's any. So yeah, best avoid any. But it is it's a bit of a way, if you've got a big system and you want to start using TypeScript with it, you've got a lot of JavaScript and you don't have the time or the resource to add all of the type level code to that JavaScript. You can add sort of just type level any, and for the things that it causes problems with, and resolve to go back and resolve that technical debt at a later point. Yeah, so there's a question about why would you use a type over an interface? They seem to be doing the same thing for defining an object structure. So yeah, and it's worth saying like everything in TypeScript is a type. For the purpose of this demo, it's a simple way to create a shape. But yeah, you could use interface, and I guess it comes back to the thing about types or classes. I guess it depends on what your what your standards are where you work, what people are familiar with as to the format of how you do things. Oh, this is an interesting question. So how do you try and win the rest of your team around to TypeScript? I mean, that TypeScript sells itself, surely. You know, we've just kind of seen the benefits of it. So I think that the way to win the rest of the team around is, you know, when you have production issues and people having to jump on things, you've got problems that mean that people are having to work slightly later to get things finished and things, and those problems are related to JavaScript null and undefined errors. I think with anything, that's how you win the team around, you know. I think with anything, you know, the way to win your team around and the way to really make the decision about whether to introduce the technology is what's the value to the team, and that value should be tangible, right? So you should be able to say kind of, you know, we've had 6 null and undefined errors that have taken 6 days of developer effort to look into. You know, we can get around that and avoid that if we use TypeScript, you know. So what are the tangible benefits to your team? Do a bit of a knowledge sharing session as well, you know, like this one, just kind of put together some examples of how things can be problematic with vanilla JavaScript, and how you can resolve those issues with TypeScript. You know, ideally a real world scenario as well. If you've had an error or a bug that's been caused by a null or undefined JavaScript thing, if you can show how that would have been avoided with TypeScript, then it's a no-brainer, you know. Are there any dangers regarding typecasting properties as any, or using exclamation marks to assert non-null properties when there could be? 100%. The danger of accepting any into something is that it will. Let's see. I must have changed that in a bad way, but yeah, if we take any in, let me just comment that out for now so that I can write some code that will compile. So yeah, if we now it doesn't like log animal. Let me just move that further down. So yeah, the problem that you've got with any is, let's see. So let's just say it's test function. Let's see. So let's call this function test, and test is going to let's say test takes in something, and that something is of type any. Then we can say, just to go back to the very first sort of example. So let's say test say console.log, and let's log out something, and let's try, see if this works. Something dot length. So you can see here, yeah, for to jump back to the question, the danger of typing something as any dangers regarding typecasting properties as any. Yeah, so if we typecast it as any, we can call anything on there and we could, so you could say test red, which will work, or will hopefully work. Got to say the demo gods have been quite kind to me. I don't think anything has failed that I didn't intend to show as failing because of the TypeScript checking that we would expect. So you can see there it's logging out red and 3, but if we change this to be null, we can pass that in, and we can, let's see, we're back in the kind of the null and undefined errors. So any basically just leaves you open to all of the JavaScript null and undefined errors. So in terms of the value of changing all of your JavaScript files to TypeScript and just allowing any and keep writing code that allows any, there is no value in that. In fact, it'll give you a false sense of confidence that that you're using type checking because you're using TypeScript. But if we change this to be string, and this is the thing, I would just use any on any really problematic things that are going to take a lot of like TypeScript code to get working if you're converting your JavaScript to TypeScript, and just as a starting thing. So now you can see if we change that to be typed to a string, it won't take null, but it will take the string. Cool. So let's see. You can allow JS within TS config, and you can also use declaration files to type JS without writing a TS file. That would be the fastest way to implement TS's benefits while converting. So still no need for any, definitely no need for unknown. Cool. So yes, someone's suggestion there is to help with converting. You can use declaration files to type JavaScript without writing a TS file. And that would be the fastest way to implement TS's benefits. So yeah, for anyone who does want to avoid using any as a halfway house, that sounds like it could be a valid option. And you can convince your team by reminding them how many times they've failed build over something silly. Yes, it's a good point. Yeah, it might not even be a failed build as well. It might be that it builds, but there's bugs and everything kind of found further down. So I think that's all the Q&As covered. So there's probably quite a lot in the chat here. It might be worth, if anyone does have anything they've put in chat that they want to kind of discuss now or ask, stick in the Q&A.
Yeah, there was quite a bit of discussion going on in the chat throughout. Cool.
That's good. Yeah, and it looks like it's all just general chat about TypeScript rather than questions, which is awesome. I'll catch up on that after the session. Yeah, because it's good to hear other people's comments and suggestions and things. Cool. Let's see, there is one more Q&A just popped up. Do you know what features TypeScript has which can't be achieved with JS-Doc TS? I don't, to be honest. I've not used JS-Doc TS, so I'm not sure on that one. But yeah, definitely something I'll have a look into after this session. Cool. That's probably it from me on this one. So yeah, so like I said, I'll hang around afterwards for if anybody does want to chat a little bit more about Mkodo, the organization that I work at, kind of how we work and the open roles that we've got available. As I mentioned earlier, for any of those open roles that I mentioned, the iOS dev, the Android dev, the React dev, which we do use TypeScript for, and the QA roles as well. Reach out to Lucy Kay from Ronald James, who's waving at you right now, and Daniel Blackwell as well, who's also at Ronald James. So you'll be able to find them on LinkedIn and things like that. I'll hang on now for anybody who might want to hear more about the organisation and the open roles, or the ways that we work as well.
Perfect. And thank you so much as well, Phil. That was great, really interesting stuff. I'm sure, like, just seeing from the chat, it was really great to sort of see so much discussion going on as well. So thank you so much for your webinar.
Cool. Thank you very much.
And yeah, I mean, what I'll do is I'll send out an email tomorrow to everybody that's attended with my contact details as well, but as well as Phil's. So if you want any more information about the roles of Mkodo and things like that, you're very welcome to drop us a message. So yeah, you got some lovely comments there in the chat as well, Phil.
Yeah, it looks like there's been a few people as well who've been chatting throughout and answering people's questions and helping them out. So yeah, thank you. Thanks for everybody who's come along as well, because webinars and things aren't anything if there's no one there to attend, So yeah, thanks everyone for coming, and thanks for engaging as well.
Yeah, thanks so much, everybody. This is being recorded as well. So if anybody wants to sort of watch it back or anything like that, feel free to drop me a message as well. I'm not sure if Phil, do you want to give a little bit more? Oh, my phone going. My phone ringing in the middle of it.
So somebody ringing to say, is the session finished yet?
Somebody ringing and said, no, it can't be over. I didn't realize it was that quick for people wanting to find out about your roles, Phil. People can't wait to hear about the photo. I'll let you sort of give a little bit of information about Mkodo as well and about the roles.
Cool. Yeah, so I'll jump into that now. But yeah, thanks for everybody for the TypeScript side of things, and hopefully it has been useful. It looks from the comments as if it was. So that's brilliant. Let me open up. I guess probably worth going to Mkodo's website, and I'll start talking a little bit about what we do. So yeah, Mkodo, I guess first thing worth mentioning is we work in the online gaming sector. So it's a very regulated sector, and it covers quite a few things. So we types of apps that we work on are we do sports books, so like your sports betting apps. We do casino, we do bingo, and one of our biggest bigger clients and things that are coming in now is lottery. So we do a lot with lottery. We were actually bought out by a big Canadian lottery company about a year and a half ago. So a lot of our bigger clients are coming from North America and Canada. You can see down here in the clients that we've got, and have a look at our website. There's a lot of stuff on there. You probably see adverts on the TV for things like Grosvenor Casinos, Mecca Bingo, and things like that. But things like OLG, just as an example. So OLG is one of our big Canadian clients, and we've been working with them to do an Android and an iOS native applications, native mobile applications for their lottery web app, basically. It's been a really big project. It's probably been a year and a half kind of to get the first release out. And that went out a couple of months ago, and that's already at 1 million downloads. It's just past 1 million downloads, I think, last week. So we're talking about really kind of, really high usage for these things, really scalable. We get, with lottery, you get spikes if it's been a rollover and things like that. So the apps that we do, the websites, the mobile applications have to be, super scalable, really performant. The regulated industry that we work in, they've got to be really secure. It's a really interesting kind of sector to work in. The people on the teams at Mkodo, so we have a really high standard of, and I count myself out of this. I'm speaking about the other people in our engineering community. We've got a really high standard of engineers. We have a real focus on things like, the solid principles, clean code, clean architecture, and the things that those kind of more recent books and principles are based on. So, things like domain-driven design, refactoring by Martin Fowler, all of that stuff. We do a lot of personal development in terms of training and katas and bringing people on, and pairing and just solving kind of problems in a kind of coding dojo style way, kind of practicing good practices, so that when we do it for real in production code, we do things out of practice rather than having to work out how to do them when we do them in production code. So yeah, the teams that we have, we're very much agile kind of scrum teams. So we work, different teams might work slightly differently, but in general, there's 2-week iterations, estimating in story points. We've got generally about 6 to 8 software engineers on a team, and they might be split across different disciplines. So it might be a couple of iOS engineers, a couple of Android engineers, and a couple of web developers. We've got like quality engineers on the teams. We've got business analysts and project managers who essentially perform the Scrum Mastery type of role as well on the teams. We very much follow the DevOps mindset. So we have CI/CD. We use Jenkins for our CI/CD pipeline. We've got things like SonarQube in that for the automated checks and reports before things get deployed. We use GitLab, so we use Git as our source control. We use GitLab for our remote. But check out our website for our clients. There's kind of test, there's kind of profiles from our clients talking about the work that we do for them. And we do have show reels as well that show off the work. So check out the stuff that's on the website. In terms of code, like I say, we really do follow a kind of clean code, clean architecture, solid principles mentality. So it is very much, we have a bit of a training period at the start where we do katas with our experienced engineers, and we really focus on a test-driven development approach. And really focus on that clean code, kind of solid principles and polymorphisms, solving things with object-oriented paradigms. Like I said, technology-wise, CI/CD pipeline is Jenkins, GitLab for the remote, and just to recap the kind of the technologies we use in the apps themselves. It's iOS is Swift. Android is Kotlin, and for the web stuff, it's React. And with that, we use Redux, we use Next.js, and we use TypeScript. So for anyone who found tonight interesting and wants to do more TypeScript, that could be a role you might be interested in. And we're big on automation and like test automation as well. So if there are any automated testers out there, as well as manual testers, we're looking for. But yeah, automated testers would be brilliant to find. We do have 2 offices in the UK. So we've got an office in Newcastle. You can probably tell by my sophisticated accent, that's the one that I'm aligned with. I live in that region, and that's the one that I go into. And we've got an office in London as well, which I'm actually going down to tomorrow to visit and meet face to face with some of my colleagues. At the minute, we do check out our website for our benefits. We've got the usual kind of things like cycle to work. We've got tech loan schemes. Employee discounts at various well-known shops and brands. But yeah, one of the, like our way of, someone's put a thing in, can't beat a Palmo in Teesside. Yeah. Do you know what, that's really thrown me off, and it's got me thinking about tea now and what kind of I might order on Just Eat after this session.
Sorry, that's my fault. Somebody mentioned Middlesbrough. I just associate Middlesbrough with
Palmos. Yeah. I might have one after this. That could be quite good. But yeah, back to the benefits. Yeah, that's what I was thinking about. So we've got the usual kind of benefits, and we kind of match everyone else, I think, on the benefits that other people offer, like cycle to work schemes and things like that. But what we're doing at the minute with getting back into the office is very kind of flexible working. So our kind of hybrid approach, and we're expecting this to be our kind of ongoing approach, is an average of 4 days a month in the office. So, you know, people might go in for 2 days one sprint and then not go in the next, and then a day the next and a day after that. But generally it kind of averages out at about a day a week. We're not doing anything at the minute to sort of enforce that everybody does go in 4 days a month, but that's kind of the expectation, is that, you know, if there's like a team meeting, or, you know, it could be good to gather with your colleagues for something for a day, then, you know, around 4 days a month is kind of the expectation of going into the office. And like I say, we've got a big focus on that whole kind of, you know, a lot of companies, where when they recruit, they ask questions about solid principles and clean code in the interview, and then when you actually look at the code when you start, or if you try to follow those things or follow TDD, you get told not to, because it takes too long and people just want to get features out. At Mkodo, we really value that stuff, and you know, we're prepared to spend, you know, quite a substantial time on personal development when people start, like 2 to 4 weeks, to bring people on in those areas if it's areas that they don't have joining us, you know. So yeah, so that's pretty much the organization, the teams, the roles and the technologies that we use. So is there another question?
Yeah, I think you've just had one last question there from Jack. He's put it in the Q&A, and I'll let you go.
Cool.
I'll let you go get your palm.
PWAs. So what is that, Jack? Just jog my mind there. If it's something I might not know about it, if it's something that I don't know about. Progressive web app. Yeah, so what was the question? Do you want to just repeat the question, just so that it's so I know what specifically the question was? Cool, just give me a second. Are any of these games progressive web apps, or would the React developer be responsible for Mkodo.com solely? Yeah, so the games are kind of they're loaded in different ways. So some of them are kind of some of them are loaded across the web. It depends really what the client kind of wants. And yeah, some of the games are kind of web apps that are kind of written in. You know, they are web apps, and it's the native code is literally just a browser control that is that's, you know, loading that web app. And yeah, some of them are kind of loaded in various ways. And I'll hold my hands up here. I'm a bit of a newbie when it comes to the mobile side of things. My background is web, and the projects that I align to more at Mkodo is the website. So I'm probably not the best person to answer this question, but I know that we do some. Generally, our native code is, you know, Swift and Kotlin, and the games are kind of running in those ways. Some of the things do a lot like that, and then they also load some games from the web, and some of them are kind of literally browser kind of controls that load, you know, a web app that looks like it's a mobile app, but is actually a web app that's showing as inside of the container of an app on the mobile phone. So I'm probably going to apologize. I might have disappointed you with that answer, but if you maybe ping that question to someone like Lucy or Dan, they'll be able to get that to me, and I'll be able to get a response back out to them from the people in who would know that and be able to answer them if it's something that you wanted to know more about at Mkodo. But if anybody as well, if anybody does, I've just been distracted by it. You know what? I shouldn't look at the chat while I'm talking because I do get distracted. If anybody does have more questions or anything, or just has an interest in the roles, then yeah, reach out to Lucy and Dan, and they'll be able to get any questions back back to us. In terms of salary, if you catch up with Lucy and Dan, and they know the salary bands that we're recruiting for, so they'll be able to discuss salary alignment with you, and whether your salary expectations match kind of what we're after. So they should be able to quite quickly rule out any disappointments, and we would never get into the process of interviewing or anything like that if salary expectations weren't aligned at that point.
Perfect. Well, thank you so much. Yeah, if anybody wants any information about the roles at Mkodo, yeah, please do drop me a message on LinkedIn. I'll send out all of my contact details and things like that in sort of a message tomorrow, as well as sort of a link to the recording as well if you want to see watch it back. So yeah, thank you so much, Phil. Thank you so much for your time and for creating a great presentation, demo and everything. Thank you so much, and thank you for everybody attending.
Awesome. Yeah, thanks just to echo that, thanks for everyone who attended, and see you guys later. I'm off to eat a palmo, I think, now.
Enjoy.
See you later.